In this video, we're going to take a look at section 2.3, which is finding domain and range. Now, our first objective is to find the domain and range of a function. Let's take a look at the definitions. The domain of a function is the set of all x coordinates. The range of a function is the set of all y coordinates. Okay, so a domain is your x values, and then the range is your y values. Let's take a look at an example. Now, in this particular example, we're just given some points on the rectangular coordinate plane. So let's go ahead and figure out what our domain is. Okay, so we're going to use set notation here. And all we have to do is just read off what our x values are for these points. For this particular point, our x value here is 1, 2, 3, negative 3. Then our second point right over here, our x value is negative 2. Then we have this point, the x value there is 0. We have this point, the x value there is 2. And for this last point, we have 5. And now we have our domain. Now the range is the y values. Okay. So let's take a look at the dot right over here. Okay, our y value for that point is 3. Then we have this point, our y value is negative 2. Then we have this point over here, our y value is negative 3. Now for the green point, the y value is also positive 3. But notice how we already have 3 in our range, so we're not going to write it again. And we have this particular point which shows 2. And now we have our domain and range. Now, one thing you could do with your range is just write it in ascending order. So you have negative 3, negative 2, 2, and 3. Let's take a look at another example. For the function f of x whose graph is shown below, determine each of the following. So it says the number in the range that is paired with the input 1. So essentially what this is saying is find f of 1. Okay. So in other words, it's saying find the y value when your x is equal to 1. Okay. So let's take a look at where x is equal to 1, which is right over here. And you have to find the corresponding y value. So go down until you get to the point on the graph where x is 1. And then our y value for that, we have f of 1. This is equal to negative 4. Part B, find the domain of f of x. Now, what makes this graph different from the one that we saw above? The one above was just a bunch of points. They weren't like connected with the line. Now, if you take a look at this particular problem, this time we have the graph, it's connected. We have this whole line right here that's connecting these 2 points. So our domain in this case, just remember it's x values. So our x values span from right over here all the way to over here. So what are those values? We have negative 1, negative 2, negative 3. So our domain in this case is going to be negative 3. All the way up to positive 3. Notice in our domain over here, we're writing it out as interval notation because we have to include all of these x values on the graph since it's all connected. Next is saying the numbers in the domain that are paired with 4. So when it's referring to the numbers in the domain, what we want to do is figure out what our x values are when y is equal to 4. So let's take a look at when y is 4, which is right over here. So we have to figure out what those x values are. So we have this point. So we have the x value 3. And we also have this point over here, which is negative 3. Now the range of f of x, so the range of f of x is our y values. So let's take a look here. So the lowest our graph gets to is right over here, and then it goes all the way up to this part right over here. So our range, so we have to include all of those values, so we're going to write this in interval notation. So we have negative 5. And notice how I put a bracket here, that's because negative 5 is included. Y could actually be negative 5. And then it goes all the way up to positive 4. Okay. So in this particular case, we were given a graph and we actually had like a line. So we have to account for all those x values in our domain, and we have to account for all the y values for our range. Another one that's similar. This time we just want to find the domain and range. So our domain, so remember it's all of our x values. Now over here you have to be a little bit careful. These arrows indicate that this graph keeps on going on in this direction. So it's going to keep on going down this way. It's going to keep going on this way. Okay, so our domain, our x values, since it keeps on going forever to the left, we're going to have from negative infinity all the way up to, and since it keeps on going on forever to the right, to positive infinity. And now our range. So once again, since this continues to go in the downward direction, we have all of these y values all the way up until this point. And when you're writing these out, you always go from smallest to largest. So our range will be from negative infinity, because it goes on, it goes down forever, and then goes all the way up to, what's that y coordinate? So this is going up by 2's. So we have our range is 4. Notice with our parentheses, notice with our infinity, it always has a parenthesis next to it. So for the last 3 examples, we were given a graph and we had to figure out what the domain and range are. For the next set of examples, we're just going to be given the function. We're not going to have the graph, and we have to figure out what the domain is. Okay, so when you're finding the domain of a given function, what you want to do is find the values that make the function undefined. The domain is the set of all real numbers except those that make it undefined. Now, what values would make a function undefined is those values that will make the denominator 0. So if you have a fraction, if your denominator is 0, anything divided by 0 is undefined. So you have to exclude those values from your domain. If you're dealing with square roots, you cannot have a negative inside the square root. So you have to exclude those values that make the square root negative. In this particular, these next examples, we're just taking a look at fractions. So we just have to figure out what makes the denominator 0. So first one, we have f of x is equal to x plus 2 all over x minus 4. So we have to find out what makes the denominator 0. In order to do that, we could just take the denominator and set it equal to 0. And now we could solve for x. So we get x is equal to 4. If x is equal to 4, it makes the denominator 0, which will make this undefined. So our domain is all real numbers except 4. So it'll be everything except 4. Now the way to write this out in interval notation, we just have to exclude the 4. So we'll have from negative infinity to 4, and we'll have a parenthesis. This means it excludes 4. We have union, and then from 4 to infinity. Okay, next function, we have f of x is equal to 4 over 3x plus 2. So once again, we take the denominator, set it equal to 0, and now solve for x. So subtract 2 from each side, you get 3x is equal to negative 2. Go ahead, divide by 3. You get x is equal to negative 2/3. So this is what's going to make the denominator 0. So the domain is all real numbers, except negative 2/3. And then in interval notation, it would be from negative infinity to negative 2/3, union negative 2/3 to infinity. Last one. So g of x is equal to x cubed minus the absolute value of x. Notice in this particular function, we don't even have a fraction. Okay? We don't have like an x in the denominator of a fraction. So for this particular function, nothing will make it undefined. No value for x will ever make this undefined. So our domain give me 1 second. Let's go back. So since nothing's going to make this undefined, our domain here is all real numbers. I don't know why it's not writing right now. If we write out an interval notation, we have from negative infinity to positive infinity. Okay, so I think I got it to right now. So this is all real numbers. Okay, our domain here would be all real numbers. And then writing out all real numbers in interval notation, this would be from negative infinity to positive infinity. Okay, so that was it for section 2.3. Remember, if you have any questions, just email me.